name is Jeff Jordan. I'm an application engineer for GoEngineer for 3D printing. We're going to be talking about 3D print applications in aerospace. And I figure we'll give everyone another couple of minutes, but wanted to let everyone know we'll get started in a second. All right, so this is a presentation that I first started putting together earlier this year. I gave it once with some different examples here, and it's a really exciting presentation for us and for me personally. So, like I said, I'm an application engineer for GoEngineer. I specialize in 3D printing. There's a few of us that are specifically 3D print pre-sales. We're really interested in applications, and aerospace is, if there was one bucket that's got a lot of the cool stuff in it, it's aerospace. So I've got a cool presentation here put together for us. I think I'll go ahead and get started here. I first want to make clear that there are a lot of technologies here that we talk about with 3D printing, or additive manufacturing as we now like to refer to it. And the point I want to make is, no matter what they are, FDM, PolyJet, DLMS, SLS, these are probably the ones you'll hear most when it comes to 3D printing or additive manufacturing in aerospace. No matter what technology or material we're talking about, we're changing the aerospace industry together. Everyone's working towards the same goal, and that's new parts, more novel parts, novel ideas, better parts, more innovation. So how we get there, how that actually works, the drivers for that are these reduced cycle times, both in design, as far as designing for additive manufacturing, and then 3D printing, as far as using 3D printing as a prototyping tool. And also what's a little bit less clear if you're not really in the industry as a manufacturing engineer or involved, is we actually have a lot of ways that we use 3D printing on the manufacturing side to really help us, not only do this prototyping and design iterations, but also to reduce the time to market, which is crucial when you're spending the types of money that aerospace companies spend to develop these parts. So what that really means, what we're really delivering here is, with 3D printing or additive, is a reduced risk and cost. And that's at each stage. That's at the design stage, which I think is what most people are pretty familiar with. At the manufacturing stage, which we have presentations for that, it's really exciting, the applications that we have within manufacturing and within aerospace manufacturing in particular. And then end-use products. I don't know if everyone on the webinar knows this, but there are a lot of end-use parts flying today that are 3D printed. So beyond the manufacturing applications of, let's use 3D printing to get your real, quotes, real parts off sooner, we have a lot of companies that are using 3D printing to actually make their end-use products in aerospace. So that's really the exciting part for us. So this is a layup. Airbus announced that they're flying over 1,000 Ultim 9085 parts. So I promise this isn't going to be a data dump with printers and materials and all that. But if there's one trade name to get out of this with Stratasys 3D printing, is Ultim. In aerospace, Ultim 9085 gives us a great strength to weight ratio, and it's the only 3D printed material that's FAA and UL and a few others FST certified. So that's flameless, smokeless, low toxicity. It's great if you can produce lightweight, very strong parts within an aircraft, but if in the event that they ignite, you kill everyone on board, nobody's very interested in that. So aerospace companies have very stringent requirements for what can actually be flown, and then they have even more stringent requirements for what can be flown with passengers. So Airbus has certified this material and their printing process, and we're going to talk about certifying additive parts in a little bit here. But they've certified this material and this process to fly in their end-use airplane as delivered to the airlines. So this is the A350. You may have seen some metal stuff from the A380. Airbus is really, there's a few of them on the cutting edge to using additive. So the real reasons why this makes sense for, beyond a, hey, this is cool, streamlined supply chain. So they're actually using Stratasys to produce these parts for them. Stratasys being one of the largest 3D printer companies in the world, and the company that we sell printers for, they're actually using Stratasys to print these parts in addition to printing them themselves. So their supply chain has one other company in it, right? They submit a design, they go to Stratasys, Stratasys makes it, ships it over, and because it's already certified, you don't have to, recertify all of these parts. So even if they do design changes, and this is the real key, even if they do design changes, those new parts that come back are already certified to fly. So what that means is we have a lower overall manufacturing cost, and that's, if you're wearing a tie right now, if you're in an office with a window, that's probably what matters the most. Is nobody would do it if it didn't result in less cost. And then of course you get these vastly improved lead times and the quickest design iteration time. So what we're looking at here is one of the parts. This is a printed duct in Ultem for running through the top of the aircraft, and these have lots of configurations. So these are typically a real pain to make, and they have design requirements. This needs to flow a certain amount of gas through there. So this is an example, and the real takeaway to this, that again, if you're wearing a tie, if you're in a window office looking down at the parking lot, we're approaching a 1-to-1 buy-to-fly ratio with these parts. So when we talk supply chain management, buy-to-fly, how many parts the aerospace company has to buy for every one that they're able to, air quotes again, sell. 30-to-1 is not obscene. 100-to-1 is not obscene. So approaching 1-to-1 buy-to-fly, you need one, you buy one, they send it to you quickly, is the holy grail for all the aerospace Six Sigma guys and whatnot. So figure I'd start out with that one. This one's a little bit more obscure. You probably haven't seen a satellite, but Lockheed Space Systems recently also used Stratasys. This is Stratasys, the company, Stratasys Direct Manufacturing, using Stratasys' printers to prototype these fuel tanks. So these are the fuel tanks for an upcoming satellite. They're the largest prints Stratasys had ever done as of earlier this year when I pulled this almost 7 feet by 4 feet by 4 feet. So we're looking at cylinders that are 4 feet in diameter. Those are not midgets standing behind them, and almost 7 feet long. So Stratasys chopped these cylinders into sections, and they were able to mate them together suitably enough to do this fit test that they wanted to do. So they printed them in polycarbonate. So in FDM, as with Ultem, polycarbonate is a great material. It's very strong. It's very impact resistant. So they used 6 Fortis 900s, which are the biggest printers that Stratasys has, 36 by 24 by 36 build envelope, to make these sections, and they did it with a low 5-digit cost. So when we're talking aerospace or defense, we typically just talk orders of magnitude. Is this a 3-digit cost, like a couple $100? Is this a 4-digit cost, a couple $1,000? 5-digit cost, over $10,000, but less than $90,000 or so. So this is low 5-digit cost. I want to say they did it in the teens, and traditionally. They got this back in. I missed it. They got this back in 150 hours. 150 hours print time. Now they were running 6 machines simultaneously, so that's how they were able to do it that quickly. But we're talking a week, whereas traditional prototyping estimated at 6 months and $250,000. So we're better than tenfold decrease in cost, increase in value, as well as getting it back. Instead of 6 months, 20 weeks, we're back inside a week. So this was a huge win for Stratasys Space Systems, for Lockheed Space Systems using Stratasys. We also have another related commercial application. So United Launch Alliance. This is a joint venture between Boeing and Lockheed. They make disposable launch vehicles. This is after the space shuttle went out of commission. This is pretty much what takes everything up. They are saving $1 million annually using Stratasys 3D printing. So it seems like a lot. This is how they do it. They're mostly an integrations company. They have the IP, they do the integration, but they outsource between 60 and 75% of all of their production. So when you're outsourcing, there's a lot of, you do the design work, but that's really only the beginning of this part getting made. It has to, go into a drawing, you have to shop it out, you have to look at bids. You have to actually try and get this stuff back from the person that bid on it, and then you have to do your inspection. So there's this loop that may not have an end, and so sometimes this gets very, very costly. So they're saying over 50% cost reduction across the board on these printed parts, up to 95% cost reduction. And the reason why they're able to hit these insane numbers is because they bought a couple of Fortis 900s to have in-house. So they're actually printing their own parts for some of this. They're decreasing the amount that gets outsourced. And like we said with everything else, they're doing it faster for less money. So coolant nozzles in the rocket, brackets, covers, ducts. Currently, they're not flying any people in these, but that's what they're certifying this year. So as of next year, we'll have manned flight with these printed parts in these Atlas V rockets. So again, most of them, what they're using is Ultim 9085. If there's one thing you can remember from this in aerospace and 3D printing, Ultim 9085 is the jam. So they've certified the material as well as the process, printing in-house on their Fortis 900s, so that there's no inspection. And this becomes a big part of the presentation a little, in a few minutes here, but inspecting parts for aerospace is tedious. And with additive, it adds another element to that, because the parts might all come from the same material on the same printer, but if anything changed, the properties of the parts might change, meaning settings or orientation, what have you. So they're saying this duct that you're looking at here, this duct goes around inside the cowling. It feeds air to cooling air through this very hot part of the through aero heating. The outside of the cowling gets very hot. So this duct is printed in Ultim. They can do their design iterations very fast. You're looking at the 3D scanner targets on that, where they were just doing a little CMM on this first one when they were certifying the process. That's where this picture comes from. But they went from 140 aluminum pieces down to 16 printed sections in Ultim. That's how, if you picture the amount of time for each of those aluminum parts, how to, as far as bidding it out, getting it back, inspecting it, that's how they get this insane cost reduction, because there's cost associated to every single one of those steps. So when you're using 3D printing to cut out not one, not two, but 8, 10 steps, huge cost reductions. So these were very straightforward, and this is the last one for our commercial side. Lockheed Space Systems, we were talking about this with those satellite fuel tanks. That was a plastic part. This is a metal part. They're talking about their metal printing, which they do in-house. And this is a fairly large company, but they're saying 43% reduction in cycle time, 48% cost reduction. So this is, again, almost 50% cost reduction, even when you can figure in the insane cost of the metal printers right now and the metal powder. Because you're wasting so little of that powder, the actual part cost, even when you amortize in the price of the machine, can be competitive. In this case, almost half of what they would have spent. So they're saying for what they're doing for Lockheed Space Systems, it is absolutely the future of 3D printing. But my point is, kind of regardless of the company or what their end product is, you're seeing all of these commercial companies saving money, saving time. And that's what's going to, the fact that everyone is in step here, moving towards additive manufacturing, that's what's changing the industry for the better. So we talked about inspection. NASA has a new NDE working group. So this is non-destructive evaluation, non-destructive testing, you might have heard, but this is traditionally done after a part comes back. You would do your NDE, and you want to just make sure that this part was made how you thought it was made. And traditionally that's done at the end, right? You're not going to stop a CNC machine halfway through a cut and say, hey, what are you cutting down there? But with additive, that actually makes a ton of sense. You want to do it during the build if you can. And so these are a couple of the current NDE methods now. Eddy current, we put some current through and see how much current's required to keep that current going, and die penetration or die pen. Neither of these work very well with additive manufacturing, and this is in relation to metal parts mostly, because of the rough surface. Parts that come out of metal printers nowadays, as of right now, still require some post-processing, so you have to post-process it first before you can do either of those. X-ray CT is great, computer tomography, but it doesn't work when you're detecting cracks if they're perpendicular to the beam. If you're shooting down the length of a crack, you will not find it. You have to be, so there's some problems with that as well. So this is Dr. Jess Waller, material scientist at NASA. They're saying that they will come out with the standard for inspecting additive manufacturing parts. So it's kind of cool to see NASA taking the lead on this. It seems like it's been a while since we've seen anything like that. So they're saying unique opportunity with additive, and that's because we can do this layer by layer. And this doesn't just apply to metal parts, but that's where the big industry push is right now, is in certifying these metal parts, like Lockheed said, which are 50% cheaper. So doing this layer by layer inspection is what they're trying to hit. So that's the NASA NDE. Now, this kind of goes towards that as well. Earlier this year, $2 million plus contracts awarded to 3D printing companies. The first, to integrate predictive technology to dynamically monitor these parts layer by layer. And so right now, there are some people playing around with taking video, using visual light to take a look at these parts as they're coming together. But all you're doing essentially is strapping a camera to it, and you might not be able to see what's actually happening, as these parts are being sintered, for instance. So they're trying to come up with predictive technology, and that's led by 3D Systems, but also you'll notice Sandia National Labs, Lockheed. I mean, these are big names all over 3D printing right now for producing these technologies, for investigating these technologies. And then the other one would be, this is the Applied Research Lab at Penn State, along with Honeywell and Northrop, develop fully dense, chemically pure, flight-worthy metal parts. So this is the internal structures of some of these parts. They say they're fully dense. They may be, they may not be. There's kind of depending on the technology, DLMS versus EBM. There are a bunch of metal printing technologies that may or may not be fully dense. So this was another $1 million plus 7-figure contract awarded to feel that out, to see if they can create chemically pure flight-worthy parts. And that would eliminate some of that inspection at the end if you could prove that your method did create those. So that's the real driver here, is we're trying to eliminate that inspection at the end. So along the military and defense, even though this is kind of commercial, kind of not, it's government dollars. So America Makes, very, very cool, fairly new, last couple years, a group, and it's part of the National Center for Defense Manufacturing and Machining. So this is a government group that is trying to help all of the subcontractors that the government uses to manufacture and machine. So this was their third project call. These are only 5 of, I think there were 9 results, 8 or 9. They gave them $9 million each, or $8 million each, plus they had to come up with $11 million themselves. So we're talking $19 million projects. These are not small projects, not small grants. First one, Seamless AM Designs and Analysis. This is led by Raytheon, GE, Altair, Ansys, Autodesk, NetFab. I mean, these are huge names in 3D printing and CAD right now. Designing new design tools for additive manufacturing. Most of this has to do with metal, some of it with plastic. Creating an open architecture for third-party metal. That's going to bring the cost down. They're really looking at bringing the cost down to bring implementation up, and creating an open architecture for the third-party metal suppliers to supply and validate that metal. It needs to be, for aerospace, it needs to be traced back all the way to the piece of wrought that it came from. So what do we do for powder? Nobody knows. So GE and Rensselaer Polytechnic are looking into that. Digital threading for additive. So this is basically threading operations. You might have heard of it with computer chips, hyper-threading and whatnot. They're really trying to get higher throughput because these machines are very expensive. And if you can only get, 1 part off per day, and your machine, is costing you a few $1,000s a day, that part becomes very expensive. So Boeing, Aerojet, Raytheon, and Stratasys are trying to figure out a way for a bunch of engineers to more efficiently use the resources that they have, meaning those large 7-figure printers. And the last one, which is something that's kind of been on the fringe, but looks like it's coming around here, is low cost, what they call multi-3D systems for 3D electronics manufacturing. So currently, we can, in the aerospace realm, we can manufacture just about any part of an aircraft or space vehicle with 3D printing. Whether or not it's feasible or cost feasible is a question, but we can currently do everything except these connections between these parts. So what they would like to do is to be able to 3D print some of these connections. So, and that means conductive filaments or other ways to embed conductive material. And it doesn't necessarily have to be tiny. It can be macro-sized, but just the ability to do this so that you can actually 3D print everything all together is the goal. And we got Northrop, Lockheed, Boeing, Honeywell, and Draper working on that. I mean, you look at down these list of recipients. This is aerospace, and it's very cool from my perspective to see America Makes actually coming through, getting the funding to place here, really pushing the industry forward. So here's another one. This is actually a carryover from my last one that I just thought was very cool because of what they're trying to do. This is the University of Virginia's drone called a Razor, designed to be printed anywhere. So this is a little different, right? We're not talking about printing it at the home base and then sending out the printed parts, or we're not talking about manufacturing it but having printed replacement parts. We're saying this entire drone is printed in 9 parts. It's a 4-foot wingspan. You can see that guy holding it over his head. It's 1.8 pounds. It holds about a 4-pound payload. Currently, that's basically a phone or camera or whatever, but of course, the military is looking at what we can put on there that only weighs 4 pounds and blows stuff up. So 40 miles an hour for 40 minutes, and the prototype's been tested at over 100 miles an hour. That's not wind tunnel, that's flight. So this is designed for the DoD to be replaced or repaired anywhere in the world, replaced or repaired in under 24 hours for less than $2,500. You fly one of these things and crash it, the field team, at your forward operations base or what have you, on a ship somewhere, littoral craft, you can repair or replace the entire drone in under 24 hours for less than $2,500, making these expendable. And that would be that's the next huge tipping point for these drones is how do we make them cost a little bit less so we can use them a lot more? And along those same line here, Raytheon, they're saying now they can virtually print guided missiles. They've printed every single component individually. Their goal is to print them on demand in the field, meaning you do not have to take a load of ordnance with you. You have a printer, it's your forward operations base or what have you. You need a specific guided bomb. You need a specific missile. Print it. So the real motivators for that, you can design the internal features. This is coming from one of their additive manufacturing engineers. Everyone already knows this, right? You can design features that are impossible to otherwise machine. And they're trying new designs. So thermal improvement, lightweight structures, these are big. There's a lot of weight that goes on to ordnance that just protects the rest of it inside. What if you didn't have to have that? You'd be lighter, which means you can pack a bigger punch or fly further. And their 3D print manager is actually bringing it back to kind of what some of the commercial applications we're looking at. When you print it, there's less parts. Your supply chain is simpler, meaning even if your supply chain had 10 steps, you're now doing 10 steps for 5 parts instead of 15. But what if it didn't? What if you actually had less parts and they were simpler themselves? So your 5-step process has 3 steps or something. So your development cycles are shorter, you're getting your parts faster, your parts are already more complex. This is the goal. This is why they're looking into this. So I blew through that so that we'd make sure we covered it. I put a lot of material in there, and I guess I left myself some time for questions. GoEngineer, as a reseller for Stratasys printers, we're looking to provide design and manufacturing tools with our expertise in these applications, enabling you guys, the customers, to reduce the cost, risk, and time required to go live. And so we're talking about, again, back to the beginning, cost and risk as well as time. So, we know that your engineering teams are expensive, and 3D printing really, especially in the aerospace field, is pushing that forward faster. So I'm going to open this up. I apologize, I only have one screen today. So I want to take a look at questions. All right, looks like we just had one question. Anybody else have questions? I know we covered a little bit about materials. I didn't want to get hung up with a data dump on materials. We covered a couple of these applications and who's using it. I know we had some attendees from a couple of those places. So I wanted to open it up here to questions at this point. Let me pop this out here. And you guys can type these in the chat here. I know I've got some help here looking at these questions. Hopefully I won't miss anything. All right, well, I came in under time here by a couple of minutes. I've been happy to answer any of your questions. My email's down here on the left, jjordan@GoEngineer. My name again is Jeff Jordan. GoEngineer is where I work. I'm happy to share these slides if you guys have anything that you'd like to show internally. I don't have a whole lot of notes attached to them. Let's see what we got here. Thanks, Dina. So please shoot me an email if you have any questions about these applications or these materials, and of course, ideas for another webinar. We're always looking for cool things to show. All right, so thank you everyone for your time, and again, email me, jjordan@GoEngineer, with any questions. Oh, you're very welcome. Thanks, guys. Oh, Jacob's got a question. Applications for aerospace tooling. I didn't want to concentrate too much on the manufacturing side of things here. We're just, this is kind of a high level. Let me hit on some cool things so that people get interested. I do have quite a few tooling and jigs and fixtures examples. So please email me. Remind me you saw the webinar. I can send you send you some slides, but I'd really like to chat about it because depending on where you are and what the opportunity is, sometimes we want to actually go give a demonstration, whether that's over the web or in person. And no worries on the typo. It looks like 10 or 15 people might have seen it. Thanks for the question, Jacob. And yeah, please email me if you'd like to chat about that. I have a great presentation for aerospace tooling and jigs and fixtures. Timothy, excellent. Ultim 95, using it a lot. That's great to hear. And you're the guy running it. Wow, I'd love to hear more about that, what you guys are using it for, if you can share it. Wow, see, a job shop. That's incredible. Usually it's just the big manufacturers that are able to get a Fortis 400 or bigger. That's fantastic. Lionel, DMLS applications, there are a ton of them. Stratasys currently does not sell a DMLS printer or any metal printers, so we don't have. I didn't concentrate on that too much in the presentation, but I try to keep it to 3D print in general. But a lot of these applications are currently really just metal printers or metal applications. So a lot of these flight parts, it's easier to certify metal parts than plastic. That's currently where the industry is, but it's moving very quickly from people that are interested in metal to people that are adopting plastic because it's an order of magnitude less expensive, and so the barrier to entry is a little bit quicker. Again, if you send me an email, I'd be happy to share with you some of the specific applications I have. We've got things like bracketry all the way to GM's new LEAP engine where they're using 3D printed nozzles. Shoot me an email. Let me know. I'll share with you what I got, and maybe we'll put together a presentation just on specific applications down the road. Thank you for that. And Timothy, yeah, if you can shoot me a message, I'd love to chat with you however much you can. Thanks very much for the questions, guys. I got you out of here a couple minutes early. And please, yeah, like I said, email me with any questions or comments. I'd love to hear from you. Thanks again.